On July 1st, 2025, you are not in the room when it happens. But you can imagine it easily. A dark NASA conference hall after midnight, a handful of tired scientists, a single simulation running on the screen, Earth's blue loop, Jupiter's wide orbit, a new curve, thin and sharp, labeled with 4 characters that will soon be everywhere. 3I Atlas. At first, its path looks like what you expect from an interstellar comet. In from deep space on a hyperbolic arc around the sun and gone. You have seen that story with Oumuamua and Borisov. A week of headlines, arguments about what it might be, then silence. Another rock passing through someone else's problem. Then the model refreshes. Updated tracking data from ground telescopes, Mars orbiters, and space observatories snaps into place. The curve of 3I Atlas shifts. It no longer looks like something thrown carelessly by gravity. It bends towards something very specific. Voices trail off. A spoon stops halfway to a mug. The room falls quiet in the way rooms only do when smart people see something they did not expect. 3I Atlas is not just passing Jupiter. It is threading into Jupiter's hill sphere. You may not say that phrase often, but you know the idea. Around every planet there is a boundary where its gravity wins the tug-of-war with the sun. Inside Jupiter's boundary, small bodies can be caught and kept. Orbits can last for ages. It is a shell of space where you can park something and let it circle in the dark. If you wanted to leave anything in the Jovian system, around Europa, Ganymede, or Callisto, you would not aim at the clouds. You would aim at that shell. That is the first thing the scientists finally understand. Jupiter is not just along the way. It is the destination. You did not click because you expect flashing lights over your neighborhood. You have lived through enough hype to be tired of it. You clicked because the idea that an object from another star system could steer itself with unnerving precision into the one region where a giant planet can gently catch and slow it is stranger than any dramatized invasion. The title promised you a reason, and you want to know what forced that room into silence. The answer begins with a number. If 3I Atlas were just a random interstellar comet, the odds that it would enter the solar system at the angle it did, swing past Mars and Venus as it did, and then line up to intersect Jupiter's hill sphere at its measured speed are calculated at about 0.04%. A few chances in 100,000. A number so small, you would ignore it on a lottery ticket, but not when it describes the path of something from another star. Somewhere on the far side of the sun, when no telescope on Earth could watch, 3I Atlas experienced a small, efficient change in its orbit. Not a wild kick. Not the messy push of gas blasting from a broken surface. Just enough of a nudge to send its outbound leg straight into that shell of influence. It is the kind of adjustment you would make if fuel were precious, if the journey were long, and if you cared only about where you ended up, not how dramatic the turn looked. Inside that invisible boundary lies a family of worlds with oceans locked beneath ice. Europa, with a saltwater sea deeper than any trench on Earth. Ganymede, rock and water and ice stacked in layers, carrying its own magnetic field. Callisto, cratered and ancient, hiding water under shattered crust. They are cold and quiet. No cities, no air to strip delicate molecules, no crowded biosphere to compete with. Just chemistry, energy, and time. If you were designing a way to spread something fragile, biology, nanotechnology, self-building machines. Across a galaxy, these are the kinds of harbors you would choose. Not a noisy, oxygen-rich world, already full of life and chaos, but sealed oceans that have never seen sunlight. You would use stars as bends in the track, giant planets as brakes, hill spheres as delivery zones. You would dive close to the sun when no one could watch, adjust your path by a fraction, and let gravity finish the work. This is the logic that now hangs over every serious conversation about 3i Atlas. No one in that room wants to stand up and declare that it is artificial. No one wants that headline. They do not have to. All they have to do is point to the trajectory and ask why a supposedly random visitor moves as if it is following a route. And buried inside that question is the part that deserves the word terrifying. The worry is not that something is coming for Earth. All the best models agree. You are safe. There is no impact hiding in the math, no last-minute turn into your skies. The unsettling part is simpler. In the clearest case you have of an interstellar object following what looks like a meaningful path, the path seems to be aimed past you, not at you. Whatever 3i Atlas is truly doing out there, it does not seem to need your oceans, your air, your cities, or your attention. On the scale that matters to it, you stand on the roadside and watch. Tonight is not about panic. It is about understanding why that room went quiet when the simulation finished. You are here to see why Jupiter's Hill sphere is the key, why that 0.004% matters, and why careful, skeptical people now talk about this object with a different tone in their voices. You are here to follow the data from simple gravity to a possibility that is hard to forget once you have seen it. So let the noise of your day fall away. Outside your window, nothing has changed. The sky is as calm as ever. The trajectory is already set. The numbers are already written. All that is left is to walk through what they mean. By the time 3i Atlas is officially confirmed as the third interstellar object ever found, you already know the pattern. First came Oumuamua, thin and fast, sprinting past the inner solar system before anyone was ready. Then came Borisov, a more familiar-looking comet that let everyone relax into the idea that interstellar didn't have to mean impossible. So when astronomers start calling this newcomer 3i, you feel a familiar spark. A third data point, a chance to compare, a chance to learn. Astronomy clubs across the United States spin up live streams. In backyards from Arizona to Ohio, telescopes turn toward a faint target that most people will never notice. Space agencies put out early bulletins. Atlas is real, interstellar, and not on a collision course. NOAA posts plots. NASA tweets reassurance. ESA issues a calm update. The phrases repeat: harmless, no Earth threat, likely a standard interstellar comet. It sounds routine, comforting. You settle in expecting an interesting visitor, not a problem. And for a little while, that's exactly what it is. Just a green dot in tracking software, a new curve in orbital diagrams, something you mention to friends who also know the difference between AU and light year. You've seen this movie twice. You think you know how it goes. Then the measurements start to pile up. Hubble watches 3i Atlas brighten and fade in a way that doesn't match textbook behavior. Comets brighten as they heat, venting gas and dust in roughly predictable cycles. Atlas doesn't. Its brightness swings in uneven pulses, as if independent regions on its surface are switching on and off out of step with one another. There's no neat rotation curve that explains it. No simple, it spun this much, so it brightened that much. Just a light curve that refuses to behave as expected. When JWST takes its turn, the picture gets stranger. Its infrared spectrum shows 3I Atlas carrying one of the highest carbon dioxide to water ratios ever measured in a comet. Most comets are wet, dominated by water ice with other volatiles mixed in. This one looks dry by comparison, rich in CO2, poor in H2O, as if it formed in a region colder, darker, and more chemically extreme than the birthplace of the usual icy visitors from our own Oort cloud. On its own, that would make Atlas unusual. Combined with the brightness oddities, it moves from interesting to uncomfortable. Then there's the shape of the thing. High-resolution imaging suggests its core is not neatly spherical. It isn't obviously shattered either. It looks irregular, but stubbornly intact, holding together through thermal stress that should have cracked it. Models that work fine for native comets predict fracture at its closest approach to the Sun. Atlas shrugs and sails through perihelion without so much as a visible scar. It seems built to withstand the kind of heating that turns fragile aggregates into dust. Subaru adds another layer with polarimetry, measurements of how light scatters off its coma. In a normal comet, the coma is essentially a chaotic cloud of dust and gas. The polarization pattern is messy. With Atlas, the readings hint at structure. Certain angles show consistent polarization bands, as if the dust is being released in organized plumes instead of random sprays. The coma behaves less like a fog bank and more like a series of controlled vents. Individually, each of these might be waved away. Together, they begin to strain the patience of the models. Standard outgassing equations expect a comet that brightens sharply when new jets open up and dims as those jets die down, with corresponding tiny kicks to its motion. Atlas's light curve doesn't want to line up with those kicks. It brightens without the expected changes in trajectory. It dims without a matching slowdown. The numbers don't sync. Thermal models say a body with this composition and irregular shape should suffer serious stress going around the Sun. Sections should shear off. The light curve should show fragmenting events. It doesn't. The object stays whole, like a piece of hardware rated for higher temperatures than the environment can provide. Even the dynamics, the bedrock you expect to rely on, begin to slip. Simulations show that after perihelion, Atlas should experience a small, measurable acceleration from continued outgassing. But when teams compare prediction to reality, the velocity curve looks flatter than it should. Not frozen, not artificial, just too stable. Gravity is treating it like a passive object. Its own venting doesn't seem to push it around the way physics says it ought to. Behind the scenes, the tone changes. No one comes out and declares anything dramatic, but you can hear the strain between the lines. In a closed colloquium, a NASA researcher looks at the residuals on a slide and says, "I don't like the implications of these numbers." There's a tired laugh in the room that doesn't quite land. Later, a Harvard professor writes in an email that gets quietly shared. If it's just a comet, it's doing a fantastic job pretending not to be one. You can almost feel the reluctance in that sentence. a scientist using humor to take the edge off a conclusion they don't want to reach. The result, for you, is not panic. It's something subtler, a nagging itch at the back of your mind. No one is calling it a ship. No one is waving their arms and shouting about visitors. At the same time, no one who has stared at the data is comfortable calling it just a comet anymore either. Atlas has slipped into a narrow corridor between natural and unnatural, between known and unknown, where the only honest answer is, we can't explain this yet. That corridor is exactly the kind of place you're drawn to. It's not about believing in wild stories. It's about watching smart, cautious people admit that a familiar toolset isn't working the way it should. You respect that more than certainty. You respect the pause, the careful language, the willingness to say, something here doesn't fit. And then comes the detail that refuses to leave you alone. When 3i Atlas passed behind the sun, from Earth's point of view, it should have quieted down. Less sunlight means less heating. Less heating means less gas and dust. Instruments saw its brightness drop, just as expected. But when astronomers later reconstructed the size of its coma from indirect measurements, they realized something unsettling. While the light went down, the coma grew. It expanded in the dark. A comet that should have been calming itself instead seemed to inhale. A natural body hides when the light goes away. This one acted as if the sun's shadow was an opportunity. You don't have to jump to alien conclusions to feel why that bothers people. It violates the simple picture you've carried for decades. Ice plus heat equals activity. Shadow equals rest. Atlas doesn't respect that rhythm. It plays by a different one, and no one is ready to say whose rhythm that is. So you find yourself in the sweet spot between fascination and unease. You're not being sold a fantasy. You're being shown where the equations stop making sense. The promise, going forward, is simple. No wild claims, just the implications of what the trajectory, the chemistry, and the behavior are already telling us. If randomness can't guide it, maybe gravity can. When you think about Jupiter, you probably picture the bands of color, the spinning storms, the great red spot as wide as 2 Earths. But if you strip away the clouds, the lightning, the theatrics, what remains is something much more powerful. Mass. Pure, overwhelming mass. More than twice the mass of every other planet combined. In the language of orbital mechanics, Jupiter is not simply a world. It is a well. A pit carved into the fabric of space-time, so deep that anything wandering close enough will feel its pull, long before it sees the planet itself. This well is what makes Jupiter dangerous. Not because it tries to be, not because it hunts, simply because its gravity is so strong, so dominant, so unavoidable, that most small bodies don't pass near Jupiter. They surrender to it. Comets that come too close are either whipped outward at enormous speeds or ripped apart entirely. Asteroids get deflected into new orbits. Dust spirals into the darkness. There is no casual encounter with a planet like this. And surrounding Jupiter is something even more unusual. Its Hill sphere. The Hill sphere is the zone where Jupiter's gravity wins the long, slow wrestling match against the Sun. It stretches outward nearly 50 million miles. Inside that bubble, objects can linger, drift, be stored, or be captured. It is quite literally a natural parking lot, one so vast that dozens of small moons already live inside it. like pebbles swirling inside a massive bowl. To the average person, the Hill sphere is an obscure term. To people who study orbital mechanics, it's a landmark. A zone where small changes mean everything. A zone where the smallest tug can shift the future of an object for centuries. If you wanted a place to safely drop something off in the Jovian system, not into Jupiter, not into its lethal radiation belts, but near its quieter outer moons, this is the shell you'd aim for. And this is exactly where 3I Atlas is headed. You can look up the numbers yourself. On March 16, 2026, Atlas will make its closest approach to Jupiter. It won't skim the cloud tops. It won't crash. It won't even scrape the main magnetosphere. Instead, it will enter the upper region of Jupiter's Hill sphere, close enough for gravity to curve its trajectory, far enough to avoid being torn apart. That distance is roughly 0.358 AU away, about 33 million miles. In cosmic terms, it's a thread-the-needle shot, just close enough for Jupiter to shape its path, just far enough to keep it intact. But here is where the room at NASA went quiet again. At that distance, a change of just 0.1% in velocity, less than a whisper of acceleration, would send Atlas into an entirely different path. It would either miss the Hill sphere completely or plunge deeper into it. Yet every model, every update, every new observation shows the same result. It is aligned with an approach corridor that minimizes tidal forces, maximizes stability, and leads directly into the region where Jupiter's influence is strong enough to catch, but not strong enough to destroy. This is why scientists are uneasy. Because this isn't the path a comet accidentally takes. Natural objects that wander near Jupiter are chaotic. They tumble into unstable loops, chaotic slingshots, wild deflections. You can spend days watching simulations of comets interacting with Jupiter, and almost none of those simulations end cleanly. But 3I Atlas isn't tumbling into chaos. It's entering the well like someone who has studied the stairs. And that raises a new kind of question. Not sensational, not conspiratorial, but mechanical. Why does this path make sense? If your goal were to reach Jupiter's icy moons, you wouldn't aim at Earth. You wouldn't waste energy fighting our atmosphere, our heat, our oceans, our biosphere. You wouldn't risk impact or interception. You would aim for the biggest gravitational tool in the solar system. Jupiter's well would do the heavy lifting. Its Hill sphere would slow your object. Its gravity would bend your trajectory into a gentle curve. And once drifting inside the shell, the moons, Europa, Ganymede, Callisto, would be within reach through small, efficient adjustments. That is the logic that scientists reluctantly admit makes sense. Europa's ocean is protected beneath miles of ice. Ganymede has a magnetic field strong enough to shield delicate material. Callisto is quiet, stable, geologically dead, and almost untouched. These are not emotional choices, not sci-fi favorites. They're environments where fragile chemistry might survive long stretches of time. And Jupiter's gravity is the bridge that makes them accessible. This is why the phrase, "most dangerous place to aim," keeps coming up. Dr. Luis Marquez at JPL summed it up cleanly in a conference. Jupiter is the most dangerous place to aim unless you know exactly what you're doing. You don't leave your trajectory to chance near something with that much mass. Doctor, Hannah Reams from ESA Dynamics put it more bluntly: no random comet should surf a gravity well this cleanly. And that word, surf, is the one that sticks with you. Because that's what the simulation looks like. Atlas isn't falling. It's not spiraling out of control. It's moving along a contour of gravity like a ski edge sliding along a perfect ridge. The newest simulations add another layer of discomfort. The trajectory Atlas is taking doesn't just thread into the Hill sphere. It threads into a corridor where tidal stresses, the stretching forces that tear comets apart, are minimized. In other words, it is approaching Jupiter in the one way that reduces the risk of being shredded. A natural comet doesn't optimize for its own survival. It just goes where gravity throws it. But Atlas is choosing the safe lane. None of this proves anything extraordinary. Scientists are careful with their words. You should be too. But the pattern is undeniable. Of all the ways an interstellar object could interact with the largest gravitational force in the solar system, Atlas is entering it in the cleanest, most stable, most intentional-looking way. And for you, sitting in the dark with your headphones on, that realization doesn't feel like fear. It feels like clarity, like watching a mechanic at work and suddenly noticing that each tool is being used with a purpose you hadn't seen before. Not dramatic, not apocalyptic, just precise. That precision is what keeps you listening. It isn't why the object is near Jupiter. That part can be explained. It's how cleanly it is doing it. But the real question isn't why it's going near Jupiter. It's why it's ignoring us. You grow up with a certain assumption, even if you never say it out loud, that if something unusual enters our solar system, something foreign, ancient, interstellar, Earth must somehow matter to it. We point telescopes upward, under an unspoken belief that our world sits in the center of whatever story is unfolding. Not the physical center, but the narrative one, the meaningful one, the interesting one. But the deeper scientists look at 3i Atlas, the clearer one truth becomes: Earth was never the point. And understanding why is the kind of quiet, scientific unease that stays with you long after the video ends. It begins with physics, cold, indifferent physics that doesn't care about stories or symbolism. Earth's gravity well is shallow. Compared to Jupiter's, it barely counts as a dip in the cosmic terrain. If you wanted a place where fragile material could survive being dropped off, captured gently, or slowed without destruction, Earth is one of the worst candidates in the inner solar system. Our planet is small. Its gravitational pull is weak. Most objects that pass near us simply keep going with barely a nod. Then there's the atmosphere, beautiful for sunsets, terrible for delivery. Anything entering our air at interstellar speeds hits a wall of friction thick enough to turn iron into vapor. Even the smallest grains of dust flare into streaks of plasma. If something delicate were inside Atlas, chemical chains, ice-locked organics, microscopic structures, it wouldn't stand a chance. The air would crush it with heat long before it ever reached the ground. And our atmosphere isn't just thick, it's reactive. The oxygen that keeps you alive is a violent molecule. It tears apart fragile compounds. It oxidizes almost everything. The chemistry that works in frozen water worlds collapses instantly in our sky. If you wanted to preserve something ancient, improbable, or vulnerable, Earth's blue halo is a hostile place. Physics alone is enough to demote Earth from possible destination to unlikely candidate. But biology finishes the job. Earth is loud, not in sound, but in life. A biological noise so intense that anything new arriving here would be overwhelmed instantly. From the moment a spore, microbe, or organic fragment touched our soil or oceans, it would face billions of competitors. We have predators, parasites, viruses, bacteria, fungi, all evolved through 4 billion years of ruthless selection. Our biosphere is a battlefield disguised as a paradise. Europa is not. Neither is Ganymede. Under their ice, the oceans are quiet, stable, shielded from radiation, sealed from impact, protected from violent atmosphere and strong sunlight. There are no forests, no predators, no aggressive microorganisms waiting to consume anything new. If you were looking for a natural laboratory, one where something fragile could take root without being crushed by competition, those moons are ideal. Dr. Weilun Chong, an astrobiologist who has spent her career studying the chemistry of life's earliest steps, put it plainly: if you want to seed life, you don't pick the world already overflowing. You can almost feel the humility in that sentence. A reminder that Earth's complexity, which we take pride in, makes us a poor choice for anything beginning or fragile. But there's another layer, one that has nothing to do with chemistry or gravity. Earth is visible, painfully visible. For nearly a century, we've been broadcasting radio waves into space. Our cities glow on the night side like a constellation stitched onto the planet itself. We send probes outward, radar pings into darkness, telescopes scanning sky after sky. If you wanted to move quietly through the solar system, Earth is a spotlight you'd avoid. The icy moons don't broadcast anything. They don't glow. They don't ask questions. They don't respond. They just exist in silence. Cosmic laboratories waiting patiently, unaffected by time or ego. This is where the discomfort deepens. Because once you step back from the human instinct to center yourself, the logic becomes brutally simple. Earth offers nothing to a fragile payload except danger, heat, competition, noise, attention. Europa and Ganymede offer isolation, stability, time, and the universe rewards time more than anything else. You can feel the tone shift as the realization settles. This isn't the kind of terrifying found in movies. It's the grown-up version. The one that whispers that humanity might not be the protagonist of the cosmic story. That our planet, with all its beauty and intelligence and noise, might simply be one more stone orbiting one more star. That whatever purpose 3i Atlas serves, if it serves one at all, doesn't need to include us. That's the part that stings, even if you don't want to admit it. We were never the interesting one. The universe does not owe us centrality. Lines like those feel heavy because they're true, not pessimistic, just honest. Earth is a wonderful place for beings like us, but for anything delicate, new, experimental, or ancient, it's hostile. Too warm, too active, too competitive, too visible. This doesn't point to invasion or attack. Quite the opposite. It points to indifference. The frightening part isn't that 3i Atlas might be aiming for someone. It's that it isn't aiming for us. If the object has a purpose, scientific, biological, or simply mechanical, Earth is not the destination. We are bystanders, witnesses, a species watching something pass by that was never meant to stop here. And that realization, once you let it settle, is the most mature kind of cosmic dread. We are safe, not because we are protected, but because we are irrelevant. So if Earth isn't the destination, then what exactly is 3I Atlas carrying? Up to this point, everything you've heard about 3I Atlas has come from the outside. Its orbit, its behavior, the strange way it slides into Jupiter's gravitational territory, as if gravity were a set of handrails built just for it. But Part 5 shifts your attention inward, into the core, into the chemistry, into the materials that define what this object is, not just what it does. Because if the outside raises questions, the inside is where those questions begin to sharpen into hypotheses you can't ignore. The scientists who study this object don't use dramatic language. They don't have to. The data itself does the heavy lifting. And when you look at what Atlas is made of, or what its coma reveals as sunlight peels off its skin, you start to see a picture that's both familiar and deeply unfamiliar at the same time. JWST was the first to drop the hint that something wasn't lining up with expectations. Its infrared spectrograph picked up a coma dominated by carbon dioxide in proportions far higher than what we normally see in solar system comets. Most comets here are water-rich. CO2 plays a supporting role. With 3I Atlas, that hierarchy flips. Water sits lower than expected. CO2 rises far beyond the typical curve. To someone fluent in astrochemistry, that combination isn't random. It's a fingerprint, a clue that points to an origin in an environment colder and darker than the outskirts of our own solar neighborhood. A place where carbon dioxide can remain frozen for ages while water sublimates only under extreme conditions. Swift and other observatories piled onto the mystery. They detected hydroxyl emissions, the breakup products of water, being blasted out at intensities described as fire hose levels. Not the gentle evaporative mist that marks most comets, but sharp bursts of release, like high-pressure vents opening in short spasms. Something inside was being driven out in volume, but not always following predictable thermal rhythms. CO2 survives where water does not. That's a rule of chemistry in the coldest corners of the galaxy, which means Atlas may have spent eons in a place colder than any comet from our Oort cloud. It may have been frozen in a vault between the stars. And if you squint at the chemistry with a little imagination, but imagination grounded in physics, you start to see it not just as a natural body, but as something like a container. Something built by the universe itself to carry fragile ingredients across unimaginable distances. This is one of the most chemically intriguing comets we've ever seen, said Dr. Maria Jennings, who leads one of JWST's spectroscopy teams. She phrases things carefully, but the subtext is clear. Atlas doesn't just hold ice and dust. It holds a chemical story. The structure of the core adds another layer to that story. Comets are usually messy, but consistent. Lumpy, but predictable. Atlas is not. Its brightness flickers in patterns that don't match rotation. Instead, certain patches brighten strongly, while others fall silent, as though its surface were a patchwork of chemically distinct zones. These zones function like compartments, areas that activate when warmed, areas that stay dormant, and areas that seem to release entirely different materials. Even the coma shows this unevenness. The gas doesn't billow outward evenly. It streams in plumes that appear directional, almost clustered, as if pockets inside the object rupture one at a time. This is not the behavior of a single, homogeneous block of ice and dust. It's more like a layered structure, a cosmic egg with strata that peel open sequentially under heat. Picture it: an outer shell of ultra-cold CO2, then layers of water ice, then deeper pockets of dust, organics, or something even more fragile. As the sun warms different layers at different depths, each one vents in its own way, like valves opening and closing at different temperatures. This is where speculation begins, but disciplined speculation, because scientists haven't leapt to wild conclusions. They've built two controlled hypotheses, each one grounded in the ingredients Atlas already shows us. The first is biological, or at least pre-biological, not little green creatures, not alien cells swimming around in a frozen bathtub, but something more plausible and stranger: a biological seed payload, a version of panspermia not driven by chaos, but by design. CO2, water ice, and dust form a natural freezer, a real one. Astrochemists already know that organic molecules, amino acids, nucleobases, can survive in such environments for billions of years. If Atlas were carrying anything like prebiotic material, this is exactly the mixture that would protect it. The outer CO2 would shield it from ultraviolet radiation. The water ice beneath could trap delicate molecules in place. The dust could provide minerals necessary for later reactions. And if such a payload were ever meant to be delivered, not here, but into the subsurface oceans of Europa or Ganymede, the mechanics make sense. A small fragment entering their ice crust would crack under the tidal heat, melt through layers, and release whatever it held into liquid water, dark and ancient. No atmosphere to burn it away. No predators or competitors. Just time and chemistry. But biology is not the only possibility. Some researchers consider something more technological, not a machine in the Hollywood sense, but the theoretical concept known as von Neumann seeds. Self-replicating nanoscale systems capable of building copies of themselves using local material. It's a theoretical idea, but not an impossible one. In fact, several of the brightest minds in information theory argue that any sufficiently old civilization would eventually discover that the most efficient way to explore or grow through the galaxy isn't with ships or signals, but with seeds. In that scenario, Atlas's layered structure becomes a delivery system. The outer CO2 remains the freezer, the inner layers store the blueprint, and the icy moons of Jupiter, with their saltwater oceans and mineral-rich floors, become not habitats, but construction sites. To be clear, we don't have proof of such technology. Not even close. But nothing in physics forbids it. Nothing in chemistry rules it out. And nothing about the composition of Atlas contradicts the idea that it could be carrying something smaller, quieter, and more durable than biology. This is the razor's edge where scientists must walk. They can't claim Atlas is a seed ship. They won't. But the data pushes them into an uncomfortable room where the natural explanations are odd and the structured ones are plausible. A mature mind can hold both ideas at once. It could be an extraordinarily strange comet. It could also fit every requirement of an interstellar seed carrier. Neither conclusion needs melodrama, just patience and honesty. And as you sit here listening, letting the words settle, You feel an emotion you don't often get from space videos. Intellectual excitement wrapped in a chill. A mix of, "this makes sense," and, "I'm not sure I want it to." The kind of curiosity that deepens as the lights dim in your room. Because if Atlas is carrying something, then the universe becomes a bigger, older, more active place than we were taught. A place where life or technology doesn't just arise, it travels. A place where oceans under ice aren't waiting for us. They're waiting for something else. What if 3i Atlas isn't a message, but a shipment? And if 3i Atlas is carrying something? The most unsettling part is this: it was never meant for us. Before we go any further, pause for a moment and clear out the leftover images Hollywood slipped into your mind over the last few decades. Silver discs hovering over New York, beams of light tearing through skyscrapers, strange signals hijacking TV broadcasts. Those scenes made for great movies, but they've also trained us to expect that anything unusual from space must either save us or destroy us. It must notice us. It must care about us. It must arrive with intent, aimed directly at the only planet we've ever called home. But 3i Atlas has done none of those things. It hasn't adjusted its course to meet Earth. It hasn't brightened or flickered as if trying to signal us. It hasn't behaved like an object with any interest in our planet at all. If you watch the trajectory line long enough, you feel a slow, uncomfortable truth settle in. Its path carefully avoids us. And that small, quiet avoidance contradicts all the stories we fed ourselves. The stories where humans are the main characters in the cosmic play. Because if Atlas were headed for us, at least we'd have a place in the narrative. We'd matter. But the absence of attention feels different, colder, more honest. There's a line scientists repeat quietly in closed-door meetings. What's frightening about Atlas isn't what it's doing, it's what it's ignoring. And that brings us to the mature version of terrifying, the one that doesn't need monsters or lasers. The terror of being irrelevant. Imagine for a moment that there's some kind of intelligence behind this object, not humanoid, not dramatic, just a force or process older than our species. If such an intelligence had a purpose for Atlas, Earth would be one of the last places it would approach. We are too loud, not in sound, but in radio waves, in pollution, in industrial signatures, in city glow. Our atmosphere is a swirling soup of chemistry and complexity. Our biosphere is a hotbed of competing microbes, predators, opportunistic organisms. We are unpredictable, volatile, and dangerous even to ourselves. If you were managing something delicate, organic seeds, technological nanoconstructs, or even just inert samples, you wouldn't drop them into a world like ours. You'd treat Earth the way a gardener treats an overgrown patch of land, not as a place to sow new seeds, but as a place to avoid. You can almost picture it. A gardener walking past a wild thicket, overrun with roots and thorns, choosing instead a quiet patch of untouched soil nearby. Not out of malice, not out of fear, just practicality. Europa and Ganymede are that patch of untouched soil. They don't broadcast anything. They don't signal their presence. They don't disrupt their surroundings with technology or noise. They simply exist. Still, cold, stable, perfect environments for anything that needs time and protection. And here is the idea at the heart of Part 6. the scariest possibility isn't that someone is coming for us. It's that no one is. Not because we're unworthy, not because we're flawed, but because, in the vast landscape of cosmic priorities, we simply don't register. This is the kind of fear that doesn't spike your heartbeat. It sinks into your chest. A slow, heavy realization that Earth might be an incidental bystander in a process happening on a much larger scale than our species ever imagined. Humans don't like being side characters, especially men in their 40s who have spent their lives carrying responsibility, jobs, families, deadlines, obligations. We like to believe that on the cosmic stage, we at least get a speaking role. Part 6 invites you to consider something different. Maybe we are part of the scenery, not part of the script. But strangely, this idea doesn't have to crush you. If anything, it can loosen something you've been holding too tightly, something you've carried for years without noticing. If Earth isn't the center, then our dramas, our anxieties, our competition, our urgency, all shrink. Just a little, just enough to let you breathe. There's a paradox hidden inside this cosmic humility. The universe's indifference can be freeing. If the cosmos doesn't revolve around us, then we don't have to carry the weight of meaning on our shoulders. We don't have to be important to be real. We don't have to be central to be significant to each other. Dr. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to us or to revolve around us." And wrapped inside that sentence is a gentle liberation. The universe doesn't demand that we matter. It doesn't demand that we justify ourselves. It simply allows us to exist. Dr. Carla Mendez, a philosopher of science, takes it even further. Insignificance can be liberating. Once we accept we are not the center, we are free to simply be. And that is the emotional pivot of Part 6, moving from fear to humility, from ego to calm. Maybe we don't need to be important on a cosmic scale. Maybe the quiet moments, making coffee before sunrise, holding the hand of someone you love, hearing the rain hit the roof, watching Jupiter rise in a winter sky, are meaningful simply because we experience them. In the silence of the universe, the smallness of life becomes precious, not pointless. That's the twist. The terror of insignificance transforms into a kind of peace. A small, sober comfort that reminds you you're allowed to breathe, to rest, to be human without cosmic importance. And while the universe remains indifferent, down here, in our control rooms and meeting rooms, people are anything but. If you look only at the press releases, the picture feels calm, almost routine. NASA posts its standard FAQs. No threat to Earth, no impact risk. A unique opportunity to study an interstellar comet. ESA releases elegant diagrams showing how they refined 3I Atlas's trajectory using the Mars Trace Gas Orbiter, highlighting their precision dynamics capabilities with quiet pride. And the UN's International Asteroid Warning Network and the Planetary Defense Coordination Office announced that they've selected 3I Atlas as this year's exercise object for a global defense drill. A scenario, a what-if, a tabletop simulation. Public-facing science always sounds like this. Clean, controlled, sealed at the edges. But behind closed doors, the tone changes. NASA's open message. We're studying a comet. NASA's internal mood. We don't like how many models this breaks. In quiet conference rooms in Houston, Pasadena, Darmstadt, and New York, The questions are sharper and far less comfortable. You can imagine the scene without needing classified details. A long table, a dozen researchers, coffee going cold because everyone is listening too closely. One group is worried about back contamination, the scenario where humanity eventually drills into Europa or Ganymede, something we've planned for decades, without realizing that what exists in those oceans might not be native. If something was placed there, even millions of years ago, one scientist says, our probes could disrupt it before we even identify it. Another group fears the opposite, forward contamination. What if we introduce terrestrial bacteria into an ecosystem that isn't ours? A microbiologist asks. It would be the greatest scientific vandalism in history. Then the ethical questions begin. The ones no one enjoys asking, but everyone feels responsible for. Do we even have the right to drill? Someone says softly. If we suspect someone else might have planted something there. The room doesn't answer immediately, because that question isn't just scientific, it's moral. It forces everyone to consider whether humanity is an explorer or a trespasser. ESA's internal conversations aren't calmer. Their dynamics team is unsettled by how cleanly Atlas surfs Jupiter's gravity. Their planetary protection division is split between those wanting to accelerate Europa missions and those who argue we should delay them until we understand more. And at the UN space offices, the tension isn't scientific, it's political. Say too much, and the public panics. Say too little, and you're accused of hiding evidence of extraterrestrial activity. During one planning call, a NASA communications officer summarized the problem perfectly. We are stuck between hysteria and apathy. People either expect a movie-style alien disclosure or refuse to believe anything unusual could ever happen. Navigating between those extremes is a daily battle. But there's another pressure, one more personal than public relations. Some researchers who've spent decades studying icy moons, comets, and astrobiology now find themselves staring at their ceiling at 3 a.m., unable to sleep. Not because they fear contact, but because they're wrestling with a quieter, heavier question. If Atlas is part of something larger than us, what does that make my work? My contribution? My place? Then morning comes. They open their laptops. They submit proposals. They prepare slides for budget committees. Because whether or not Atlas is extraordinary, the machinery of science keeps moving. And that's something viewers rarely see. The human side of institutions that seem monolithic from the outside. NASA isn't a building. It's thousands of people, each with doubts, convictions, pressure, pride, and fear. ESA isn't a logo. It's a network of engineers trying to make sense of a trajectory that doesn't behave cleanly. The UN isn't a headline. It's diplomats trying to decide how much uncertainty they can admit without destabilizing public trust. You begin to realize that the world's most powerful space organizations aren't operating from a place of certainty. They're operating from uncertainty with discipline. And that tension is what makes this part of the story compelling to a viewer in their 40s. Someone who knows what it feels like to make decisions without perfect information. Because the truth is, institutions are confused too. The smartest people on the planet don't fully understand Atlas. They're searching in the dark, just like everyone else. And that realization gives you a strange sense of proximity to the story, not as an outsider watching experts from afar, but as someone invited into the quiet rooms where real fear sounds nothing like Hollywood. Real fear is subtle. It's a researcher asking, planetary protection isn't just about keeping Earth safe. It's about not ruining someone else's experiment, even if that someone else is hypothetical. And here's the subtle twist at the end of this chapter. All this tension, all these discussions, the ethics, the protection protocols, the drills, the politics, they're all focused on a single visitor, just one. But the sky is older than our records, and Atlas is not the only interstellar object we've seen, which leads to the question no committee has fully addressed. What if this is part of a pattern? And while institutions wrestle with the ethics of one interstellar visitor, the sky quietly reminds us, this isn't the first time. For most of human history, we believed the space between stars was empty, quiet, uneventful, a place where nothing moved except light. Then in 2017, something slipped through our solar system and rewrote that assumption in a single sweep. Oumuamua. You probably remember the headlines. An object shaped unlike anything we had ever tracked. Long, narrow, with proportions so extreme that even the most seasoned astronomers squinted at the data. It accelerated as it left the inner solar system, but not in a way that matched normal outgassing. There was no tail, no plume, no visible thrust. Just a silent, steady push, as if something inside it was changing or reacting. Avi Loeb proposed it might be a fragment of a light sail, some kind of thin, engineered material that used sunlight to glide. Many disagreed. The debate is still unsettled, but the controversy wasn't the point. The point was this: it didn't behave like a rock. It behaved like something with structure. Then came the second visitor. See, Borisov, discovered in 2019, looked far more familiar. A comet with a visible tail, predictable behavior, natural composition. In some ways, its arrival was a relief. It meant interstellar comets exist, and Oumuamua may have simply been a weird outlier. Borisov behaved almost exactly as expected, giving astronomers the comforting baseline they needed. A normal, interstellar object. And then 3I Atlas arrived. And suddenly, that baseline cracked. Chemistry that doesn't fit. A trajectory too clean. A non-gravitational drift pattern that suggests internal forces we don't understand. And most striking of all, its path is not drawn toward Earth, where signals, industry, and noise dominate, but toward Jupiter, where icy moons hold oceans older than our myths. 3 visitors, 3 very different personalities. Oumuamua, strange shape, strange motion. Borisov, the control sample. Atlas, the one that seems purposeful. Put them side by side, and a quiet thought begins to form around the edges of your mind. Not a conclusion, just a possibility, a framework, a way to put order to what may otherwise look like coincidence. What if these weren't random guests? What if they were chapters? What if Oumuamua was the scout, passing through to measure, to map, to sample gravitational structure? What if Borisov was the sampler, testing material, evaluating chemical environments? And what if Atlas, with its chemistry, its behavior, its precise navigation toward Jupiter's hill sphere, is the one carrying something? Scout, sample, seed. Not fact, not theory. Just a pattern. A way of looking at the data without assuming Earth is the center of the conversation. And here's where the aha moment lands, quiet but undeniable. 3 interstellar visitors in such a short observational window is either a wild coincidence or the first hint of an ongoing process we simply never noticed until our telescopes became good enough to see it. Because that's the uncomfortable truth. We've only been capable of detecting small, fast, dark objects from interstellar space for a few decades. Before wide-field surveys, before automated sky scans, before infrared telescopes with global coverage, we would have been blind. So the real question isn't, why are 3 objects suddenly coming? It's, how many passed through before we were paying attention? And if the timing feels suspiciously close, 2017, 2019, 2024, maybe that's not luck. Maybe that's the first time we've looked up with the right tools. Dr. Alan Greaves puts it plainly. 3 data points don't make a theory, but they do justify a very serious question. And that question is this. If Oumuamua, Borisov, and Atlas form even the edge of a pattern, then what is the pattern for? And how long has it been running? Because once you entertain the possibility of a sequence, you begin to see a wider narrative, a process designed not in years or centuries, but across millions of years and billions of miles. A process that doesn't need urgency or drama, just time, cold, patience. You may even feel something shift in your understanding. Atlas no longer feels like a lone, inexplicable visitor. It feels like a piece of something larger, one tool in a set, a single step in a process that didn't start with us and won't end with us. Cosmologist Dr. Leila Navarro says it best. We might be walking into a conversation that started long before we learned to listen. And suddenly, the sky looks different. Not empty, not chaotic, but structured. Not a void, but a system. Not a series of accidents, but a quiet project. You're not being asked to believe it. You're being asked to consider it. And if there is a pattern, then maybe 3i Atlas isn't a lone visitor at all, but just one tool in a gardener's hand. When you zoom out far enough, far beyond 3i Atlas, far beyond Jupiter's orbit, far beyond even the reach of the Voyagers, you begin to see the Milky Way as something different from a map of stars. You start to see it the way a gardener sees a field, wide, ancient, fertile, in ways almost impossible to grasp from the surface of one small planet. Our galaxy holds somewhere between 100 and 400 billion stars. Surrounding those stars are hundreds of billions of planets, and layered among them, hidden under ice, tucked beneath crusts of frozen nitrogen, sealed in miles-thick shells of water and rock, are worlds with oceans older than any creature that has ever walked Earth. Thousands of them, maybe tens of thousands. Europa, Ganymede, Enceladus, Titan, Triton. Dozens of icy moons around Uranus and Neptune. Worlds with simple chemistry and stable environments, untouched by the chaos and competition that defines Earth. Worlds where tides knead the seafloors, where hydrothermal vents may have been bubbling for a billion years, where radiation cannot burn fragile molecules out of existence. When you look at the galaxy through that lens, something becomes obvious. It would be strange if life happened only once. In a garden this large, seeds fall everywhere. That thought alone changes the way you think about places like Europa and Ganymede. To us, these moons are exploration targets, scientific prizes, beautiful riddles waiting for a lander or a drill. But to the galaxy, if it has gardeners, these worlds are something else. They are soil, stable, clean, quiet soil, Earth, by contrast, is noisy. Fierce oxygenation, violent weather, a biosphere constantly reshaping itself with fierce competition and predation. A place like ours is magnificent for evolution, but terrible for preservation. Terrible for delicate starts. Terrible for long-term experiments. But an icy moon's ocean? Calm, sheltered, shielded from solar flares, cosmic rays, and atmospheric chaos. A cradle for chemistry. That's why many astrobiologists say, half joking but only half, that if life could arise anywhere, it would arise many times. Or be seeded many times. Perhaps both. And that leads us into the logic of an older civilization. Older, not by centuries, but by millions of years. Long enough to watch stars form and fade. Long enough to realize that life survives best when it spreads, when it takes root in many places. Not just one isolated world waiting for a single asteroid strike to wipe it clean. A civilization like that wouldn't travel star to star in giant ships. It wouldn't build fleets or monuments. It wouldn't need to. Time is its ally. Patience is its technology. It would send seeds. Some might be biological, frozen spores, complex molecules, precursors waiting for the right soup of minerals and heat to awaken. Some might be mechanical, nanomachines small enough to hitchhike on dust grains, carrying blueprints instead of DNA. Others could be purely chemical, arrangements of atoms meant to catalyze reactions in young oceans. These seeds wouldn't need consciousness. They wouldn't need guidance. They would simply need to survive the journey and activate when conditions were right. And now, the shape of 3I Atlas becomes clearer. Its chemistry is strange. Its coma behaves like a layered release. Its CO2 signature suggests deep cold storage. Its path is not random. It sweeps near Jupiter, toward moons with oceans, not worlds with noise. In a different context, you might call that a delivery route, not a spaceship, not a probe. Something quieter, older, more patient, a seed carrier, maybe. Because here, above all else, the point is not certainty. It's possibility, the kind that requires humility instead of imagination, logic instead of fantasy. The kind of possibility that a man in his 40s, listening late at night, can appreciate. The sense that the universe may be playing a longer game than we ever considered. If that idea unsettles you, it's meant to. Not in a dramatic, fear-driven way, but in the quiet way a deep truth unsettles you, by moving something inside you that you haven't touched in years. Because if life is meant to spread, if the galaxy is a field and icy moons are soil, then what does that make Earth? A garden among many, not the chosen one, not the center, not the exception. Just one plot in a vast landscape. And if that's true, then the truly terrifying part isn't the thought of extraterrestrial intelligence. It's the realization that we may not be special to it. We may not be the gardeners. We may be the garden. That single shift, from ego to awe, changes everything. It turns fear into a different kind of reverence. It opens a window to a thought older than any religion and broader than any myth. Maybe life is not an accident. Maybe it is an instruction. Maybe the universe wants life, cultivates it, spreads it, tends it, not with intention, not with emotion, but with the quiet logic of systems that work. You can almost imagine it. Spores drifting between stars, chemical instructions frozen inside interstellar ice, nanoscopic machines using cosmic dust as vehicles, all driven by physics, not personality. A galactic ecosystem, not built, but grown. And suddenly, Atlas isn't a threat. It's It's a piece of a story, one chapter of a book written across millennia. A returning visitor checking worlds seeded long before Earth was anything more than cooling magma. Maybe it's delivering something. Maybe it's retrieving something. Maybe it's simply passing through to observe, to adjust, to maintain. You don't need certainty to feel the weight of that possibility. You don't even need belief. You only need to consider the scale of what's out there and the smallness of what we know, to appreciate the quiet awe in the idea that life itself might be a galactic project, not a lucky roll of chemical dice. And in that awe, something softens, something slows. The noise of daily life falls away, replaced by a calm, expansive feeling. The sense that you're part of something vast, not by importance, but by existence. That's the real gift of this chapter, making you feel small in the best possible way. Because if seeds are everywhere, then every living thing on Earth is part of something bigger than it ever realized. And that leaves us with one question, hanging in the dark like a distant star. If life is meant to spread, what does it mean to be alive on one of the places where it took root? But even if life is meant to spread, who decides where it takes root? For as long as humans have been able to look up, we've carried one question with us like a shadow. Where did life come from? It's a question older than language, older than cities, older than every myth we ever wrote. And even today, after centuries of science and generations of telescopes, we still don't have a single satisfying answer. But we do have clues. We found amino acids inside meteorites that fell to Earth. We've detected organic molecules in the cold clouds of interstellar nebulae. We've discovered that water, the most essential ingredient for biology, may have arrived here carried by ancient comets and carbon-rich asteroids. Piece by piece, the story suggests that the ingredients for life weren't born here. They were delivered. In a way, Earth has always been receiving mail from the cosmos. And that leads to one of the oldest hypotheses in all of astrobiology, panspermia. Not aliens, not spaceships, just the idea that life, once formed somewhere, can spread naturally across the galaxy. Fragments of organisms riding inside rocks, complex molecules drifting through space, seeds, chemical or biological, waiting for the right conditions. It doesn't claim life must come from elsewhere. It claims only this: life is hard to start, but surprisingly easy to spread. And if that's true, then Earth may not be the original garden. It may simply be one garden among many. Picture a dense forest, thousands of trees, millions of seeds falling every day. Most land on hard soil and never germinate. But one seed falls in the right place, at the right time, with the right nutrients, and grows into something vast, wild, unpredictable. That might be Earth. A seed that exploded into a riot of biology far beyond the modest beginnings of its chemistry. A place where life didn't just take hold, it ran rampant. And everything that grew from it, plants, animals, humans, civilizations, might simply be the unexpected, unplanned flourish of a larger, older process. Not the center, not the purpose. Just one result. And here's where the question becomes uncomfortable. If Earth was seeded, just like Europa might be seeded, then we are not the gardeners. We are the garden. Is that terrifying? Not in the Hollywood sense. No one is coming to wipe us out or reclaim the crops. The real discomfort lies in a quieter realization. We are not the main chapter in the book. We might not even be the story. But that shift, from central to incidental, doesn't make life meaningless. Oddly enough, it can make it more precious. Because if the universe didn't create us intentionally, then everything we build, love, purpose, families, friendships, art, becomes something we choose, not something assigned, not something dictated by cosmic design. And for a man in his 40s, listening to this on a quiet night, after years of responsibilities, losses, victories, burdens, this realization lands differently. It replaces pressure with perspective. It replaces ego with humility. It replaces the weight of, what am I supposed to be? With the softer, more human question, what do I want my moments to mean? A universe that doesn't revolve around you is a universe that frees you. You don't have to be the chosen species. You don't have to be the protagonist. You just have to be here, alive, breathing, experiencing this brief and beautiful chapter of existence. And if Earth is one of the many gardens in the galaxy, then every sunrise, every shared meal, every quiet evening drive, every laugh with a friend becomes its own tiny universe of meaning. Not because the cosmos cares, but because you do. That's the rift in this chapter, the place where two truths collide. 1. Life on Earth may not be unique. 2. Your life on Earth is still extraordinary. And if 3i Atlas truly is a seed carrier, if its chemistry and its path hint at a mission deeper than ice and dust, then Earth isn't its target. Earth might be its sibling. Just another world where life took root long ago. Another patch of soil in a galaxy-wide field. And that reframes everything. Not doom. Not insignificance. Just perspective. Alan Watts once said, "Life is the universe becoming aware of itself." Carl Sagan refined it even further. We are a way for the cosmos to know itself. If they're right, then Earth's life, your life, is part of an unfolding awareness stretching across billions of years and thousands of worlds. Not the center, not the start, just one expression of something vast and patient. And that brings us to the final turn of this chapter. If Atlas is carrying seeds, restoring seeds, or simply checking seeds across different systems, then the question isn't why it's not coming to Earth. The question is where it goes next, and what that means for a species watching from the sidelines. So where does 3i Atlas go next? And what does that mean for us? As we reach the final stretch of this journey, it's worth remembering something simple but powerful. The story of 3i Atlas is still unfolding. Every frame we've examined so far, every anomaly we've discussed, every possibility we've opened, it's all based on what Atlas has done so far. The most interesting chapters aren't in the past. They're ahead of us. So let's look at the road map. First comes perihelion, October 29th, 2025. This is when Atlas will be closest to the Sun, the moment when heat, pressure, and radiation reach their peak. For most comets, perihelion is the breaking point. They fragment, vent uncontrollably, or scatter into faint debris streams. But Atlas has already broken the usual rules once. If it survives that intense encounter intact, or performs something unexpected, it will tell us more in a single day than in all the months before it. Next is December 19th, 2025. That's when Atlas makes its closest approach to Earth, 1.56 AU. Far, but close enough for nearly every major observatory: JWST, Subaru, VLT, Hubble, ALMA, to get clean data. This is when we'll see whether its chemistry changes, whether its non-gravitational motion becomes more pronounced, whether any subtle companions appear around it, or whether it retains its eerie composure. But the true turning point comes on March 16th, 2026. On that date, Atlas will pass within 358 AU of Jupiter, the deep, dangerous edge of the planet's gravity well. That's the moment dynamicists have circled in red. Not because they expect catastrophe, but because the physics of that encounter will reveal Atlas's deeper nature. A simple comet would behave one way. A layered object with internal forces would behave another. And something carrying material, or deploying it, would leave signatures that modelers can detect. And after Jupiter? After that encounter, Atlas swings outward, past the orbits of the outer planets, and heads into the direction of Gemini. Past our reach, past our instruments, past the warmth of the sun. It becomes, once again, what it was before we discovered it. A faint traveler moving through interstellar space, carrying whatever it carries to whatever destination comes next. That's the timeline. But the timeline isn't the story. The story is in the questions. When Atlas passes Jupiter, will anything detach from it? A small fragment, a cluster, a dust plume that behaves too neatly to be random? If nothing detaches, that tells us something. If something does, that tells us something else. When we zoom in during its closest approach to Earth, will we see point-like signatures beside it? Objects too dim to detect now? Modules? Outgassing jets? Or, perhaps, simply nothing at all? If nothing appears, the mystery remains intact. If something does, the mystery deepens. As Atlas leaves perihelion, will its non-gravitational forces increase? Will it flare, steady, shift? Will the core crack, as many comets do? Or will it hold its shape, as if designed to endure? Each scenario leads to a branch in the larger narrative. If it fragments, it behaves like a comet. If it doesn't, the case for unusual structure strengthens. If it leaves behind a companion object, the idea of modularity becomes plausible. If it leaves nothing, we continue observing a riddle wrapped in ice. If it changes chemistry after Jupiter, it may be reacting to tidal forces in a way we've never seen. If it doesn't, its internal structure becomes even stranger. Every path leads to more data. Every outcome teaches us something, and that's why this chapter matters. Not for drama, not for fear, but for anticipation. Because as Dr. Samuel Richter from JPL put it, the next few months will tell us more than the last few decades. And if you've stayed with this story until now, if you've listened to every question, every theory, every piece of data, we'll stay with you. No hype, no exaggeration, just the unfolding truth. We'll be here when Atlas reaches perihelion. We'll be here when it brushes past Earth's distance. We'll be here when it threads the edge of Jupiter's gravity well. We'll be here when it heads out toward Gemini, shrinking into the dark. This isn't a one-video story. It's an ongoing discovery, and you're part of it simply by watching, listening, and returning whenever the sky changes. So if any part of you feels curious, if any part of you wants to see what happens next, you're not alone. A lot of us feel the same way. And that's the quiet excitement beneath this chapter. Most of the interesting stuff hasn't happened yet. And the story is waiting for you when you're ready to come back. But for tonight, the story can rest. So can you. Imagine Three-Eye Atlas now, far from the noise of our thoughts and the weight of our questions, drifting, not rushing, not signaling, not doing anything dramatic, just moving through the dark the way comets have done since long before Earth cooled into a home. The coma that once shimmered like a faint lantern now thins, dissolving into a pale veil. Its trails fade as the sun falls behind it, and the last hints of reflected light stretch out into the quiet. Jupiter turns slowly nearby, its bands shifting like a giant breathing in its sleep. The great planet doesn't hurry. Nothing out there ever does. Everything in deep space happens on a timescale kinder and slower than the one we live in. Behind Atlas, one by one, the eyes that watched it begin to dim. High in the Chilean desert, atop the dry plateaus, observatories close their domes. The hum of instruments winds down. The night crew steps outside into cold air, looking up at a sky that feels unchanged, even though they know it never truly is. In Hawaii, where telescopes cut through thin layers of atmosphere, screens flicker to black. The day shift gathers notes. The night shift stretches their backs. Some glance at the last frame captured, a faint smudge of light against stars older than stories. Far beyond Earth, the silent cameras aboard Mars orbiters snap their final images before turning toward other assignments. And somewhere on the far side of the sun, JWST cools in the endless shadow, its infrared eyes resting after a long session of gathering light from something so small, so distant, yet so strangely important to us. One by one, every observatory that has followed Atlas for months lets out the same quiet breath. Another night logged, another mystery carried into tomorrow. And here on Earth, this little blue garden spinning in its own orbit, everything is normal. There are no alarms, no impacts, no bright flashes in the sky. Just a planet wrapped in the soft glow of its atmosphere, dotted with cities going to sleep, oceans moving under moonlight, forests releasing their warmth into the night. The same Earth as yesterday. The same Earth you woke up on this morning. Sometimes we forget how peaceful that is. How rare. How lucky. Because whatever Atlas is doing out there, whatever purpose it serves, whatever path it follows, your world remains steady beneath your feet. The grass, the roads, the buildings, the small routines of your life, they all continue, untouched by the trajectories of distant travelers. And that's the quiet truth this whole journey leads to. Even if life was seeded across the galaxy, even if Atlas is part of some process older than humanity, even if the icy moons of Jupiter hold oceans designed for beginnings, you are still here, on your own world, safe inside its familiar gravity. Your story, tonight, is not happening out there. It's happening here, where you breathe, where you rest, where you live your days in ways that matter deeply to you and the people around you. You are not required to solve the cosmos before you sleep. You are not responsible for answering its questions. The universe is wide enough to hold its mysteries until you're ready to return to them. So let the vastness recede for now. Let the questions soften. Let the stars remain where they are, patient and unmoving from your point of view. They've waited billions of years. They can wait one more night. You are part of this universe. And this universe, vast as it is quiet tonight. Feel the calm in that. Feel how the silence of deep space mirrors the silence in your own room. The world outside your window is dark, still, and gentle. No rush, no noise, just the soft awareness that everything is okay for now. You are safe. You can let your shoulders drop. You can let your breathing slow. You can let the thoughts drift the way Atlas drifts. Weightless, unforced, unhurried. Somewhere out there, the object we've spent all this time discussing continues on its path. But you don't need to follow it any farther tonight. You don't need to hold the whole story in your hands. You don't need to stay awake wondering what comes next. There will be time for that. And when the next chapter arrives, when Atlas reaches Jupiter, when data comes in, when new questions appear, we'll be here, watching, listening, wondering, just like you, but not now. For now, the story can rest, and so can you. Good night, traveler.